Our last expert talk will be by Mr. Saurabh Mukhopadhyay from John Deere Private Limited, India. Okay, so over to you, Mr. Saurabh.
Thank you, Payal, for introducing me, and thank you for the opportunity, Professor Chandan. Thank you for the opportunity for Professor Kandan. Uh, so yeah, about me, this is Saurabh Mukhopadhyay. I am pursuing my PhD from IIT Kharagpur, and also I am working in Deere and Company since last 8.5 years. So I completed my masters also from IIT Kharagpur. So I just work as a CFD-DEM analyst, and majority my expertise is in the CFD-DEM domain, particle flow, airflow in that domain, multi-phase flow. So I will share some of the means cases whatever we do in industry level, as well as also some of the cases, potential cases we are also exploring through the open source software. So that part we will go ahead and share. So let's look at it first. I think whatever agricultural product line I generally work on actually, and especially I can say that John Deere dealt with actually. So that's tilling, soil tilling. Soil tilling is regular interaction with the soil and cutting the soil, cutting the residue of the soil, digging the soil, and that part. After that, seeding and planting. If you look at whenever seeding and planting is planting the seeds into the soil, actually spraying operation, that is something a major business for John Deere. And I majorly work in this area, actually sprayer. So spraying operation, if you say, we have to model the spray, and after that how the spray is getting drifted, lot of things comes into picture. I'll cover that later slides. So harvester is that whenever, hey, crops had grown, so crops had grown at that time we generally cut the crops and take the crops and harvest the crop ultimately. So entire this agriculture cycle, if you look at, this is actually designed to show according to the agricultural cycle. Actually, if you look at the agricultural cycle, first tilling operation occurs, after that seeding, planting, and after that spraying operation, and at the end, of course, harvesting. So entire agricultural cycle is tried to cover the, through this slide. So generally where we apply CFD in agricultural product lines, so we do vehicle thermal management, underwood thermal management, also we do soil tilling, planting, metering, spraying, cavitation, FSI, tank sloshing, FSI, and also we do some sort of solution mixing, etc. That kind of problem. So we generally deal with this kind of interesting problems, and I'll first show some sort of interesting problem. If you look at, in the world of the agri-machineries. So actually, whenever spraying occurs, actually spray got drifted in the downstream. So what we do with the, spray modeling here. So primary and secondary breakup, considering the effect of the Reynolds number and the Weber number, and we model it. And after that, we have validated methodology. I cannot share further data for the purpose of the confidentiality. And yeah, so after that, whatever spray characteristics we get at the downstream, maybe 5 centimeter, 10 centimeter downstream, we use that spray data in the full model, and we get the how the spray is getting drifted, how the spray is getting recirculated in the downstream, over flow over, it is a flow over like a blob body if you see the downstream. So how the recirculations are occurring in the downstream. So that part we want to capture, we try to capture generally. So that's something interesting problem. Tank filling, for this one we use the open source software lights. So we try to understand how the material is getting filled while filling operations. We design the tank accordingly, the corners should be filled properly, there should not be any void. So that kind of stuff we generally use use discrete element modeling lights tool, and we try to model this kind of stuff here. if you look at granular segregation, this is mostly from my PhD work. So there is a common example of the CFD-DEM coupling. If you look at generally pulsed fluidization, we generally used for segregation purpose. So segregation, if we look at the segregation purpose, actually for the particles of high density and low density, actually uh, through pulsed fluidization, we often segregate them. So we use CFD-DM coupling for this kind of complex phenomenon. And of course, means we are using commercial software for this kind of complex phenomenon modeling. But yeah, so but the thing is that there's a lots of opportunity in the using the open source software. This is a implicate example of the strong physical problem, as well as if you go into the deep fundamental analysis as well as industrial applications. So we have a lot of application of the granular segregation using threshing, or in the harvester point of view, I'm saying threshing operation. There are a lot of operations often we do the in the pharmaceutical industry, mining industry, lot of application of the granular segregation using this CFD-DM coupling. So there is a lot of opportunities are there in this area to further explore and get more value added in this area. So this is something we often do. I mean, in all the industrial applications. So yeah, this is a common example of the CFD-DM coupled analysis, and we have got very good correlation with the physical test performed by Lee et al. And we have further extended the study for parametric variation of the this particle density ratio, flow parameter, sinusoidal flow parameter, as well as triangular, as well as exponential flow parameter. So that kind of stuff we often do. So yeah, again, I'm going for one of the most interesting example for the DRN company. So this is one of the most tricky actually part for the seeding and planting. If you look at seed meter, so if you look at this seed meter modeling, actually this is one of the most complex part of the DRN company. So we generally I cannot share further data about it because of the confidentiality. This is a YouTube video, you can look at it. I can also share the link. So this is something how the seed meter works actually. So there is a vacuum seed meter, and we also virtually model this kind of complex phenomenon, and we had a very good correlation on that front and using CFD-DM coupled analysis. So this kind of stuff can be used to this kind of complex capability can be utilized in the industrial level. And yeah, of course, this is for this kind of stuff we use the star CCM plus. This is a commercial software. But on the other hand, again, for the low fidelity comparatively, uh, the model of the lower level of model, we generally use kind of open source software, OpenFOAM or Light. So that's a part. Of course, there is a long way to go if I talk about the opportunities in the industry is well acquainted about this open source software. And yeah, of course, there is a long potential for this open source software in the future, and industry has a strong eye in this area. And we are definitely looking at it if we can explore further opportunity in this area. Yeah, thank you for this opportunity again to Professor Chandan Bose, Professor Kannan, and yeah, everyone, thank you for uh, listening me through.
Yeah, thank you so much, Mr. Saurabh.